Climate change and air pollution are phenomena that have emerged from the Industrial Revolution, characterized by significant increases in greenhouse gas emissions and the burning of fossil fuels. This process, which began in the late 18th century, saw rapid industrialization and urbanization, leading to a sharp rise in carbon dioxide, methane, and other greenhouse gases. The Industrial Revolution marked the initial phase where coal, oil, and natural gas became the primary energy sources for factories, transportation, and household use. Early in the 20th century, the widespread adoption of automobiles and the increase in power generation further amplified these trends, contributing to a substantial increase in atmospheric concentrations of carbon dioxide and other pollutants. Air pollution, primarily associated with particulate matter and gases such as sulfur dioxide and nitrogen oxides, emerged in tandem with the industrialization process. In the mid-20th century, cities like London and New York experienced smog episodes, which highlighted the negative health impacts of air pollution. The global temperature began to rise in the late 20th century, as evidenced by the rapid increase in global average surface temperature, now exceeding pre-industrial levels by about 1.1 degrees Celsius. This warming trend has been attributed to the increasing levels of greenhouse gases in the atmosphere, with the Intergovernmental Panel on Climate Change, IPCC, reporting an average global temperature increase of 1.1 degrees C since the pre-industrial era. The major turning points in climate change and air pollution include the adoption of the Montreal Protocol in 1987 to address ozone depletion, which also indirectly reduced certain air pollutants, and the Kyoto Protocol in 1997, which set international targets for greenhouse gas emissions reduction. Over the past few decades, both climate change and air pollution have caused significant health impacts, with air pollution being the cause of 4.2 million premature deaths annually. Climate change has led to more frequent and severe weather events, such as hurricanes, floods, and wildfires, affecting millions of people worldwide. Measurable impacts on societies, economies, and industries are evident through economic losses due to natural disasters, health costs, and disruptions in agricultural and energy sectors. For instance, economic losses from climate-related disasters reached $320 annually between 2000 and 2019, with the United States accounting for the largest share. Similarly, air pollution has been linked to reduced productivity and increased healthcare costs. In the long term, climate change and air pollution are expected to continue influencing global health, economic stability, and environmental sustainability. Projections show that by the year 2050, global average surface temperature could rise to 1.5 degrees C to 2 degrees C above pre-industrial levels, potentially resulting in substantial impacts on ecosystems and human health. To address these issues, comprehensive strategies must include international cooperation, stringent emission reduction targets, and technological innovations in renewable energy and waste management. AI can be utilized to optimize energy usage and predict climate patterns, thereby enhancing the effectiveness of climate and air pollution mitigation efforts.